All right, let's talk about something that drives every single one of us crazy: storage speed. You see these massive numbers on the box, but then in the real world, it just doesn't feel that fast. So what's the deal? Well, today we're going to demystify it. We'll break down the actual physics of why your drive is slower than you think, and I'll even show you a super simple trick to fix the biggest bottleneck. Let's get into it.
You know the feeling, right? You've got a big, like 20 gigabyte movie file. You drag it over to another drive, and whoosh, it just flies. You're seeing hundreds of megabytes per second, and it feels like magic.
But then you try to back up your photo library. It's thousands of tiny little files, maybe not even that much data in total, and the transfer speed just tanks. The progress bar barely moves, and that estimated time, it jumps from minutes to hours. It's the same drive, so what on earth is going on?
Well, it turns out your storage drive is kind of bilingual. It speaks two completely different languages when it comes to accessing data. And once you understand these two languages, you'll understand everything about storage performance.
Okay, so first things first. It's not just about one single speed. Performance is all about the pattern of the data you're trying to read or write. This is the #1 rule of storage.
So, the first language is called Sequential I/O. The easiest way to think about it is like reading a book, starting at page 1 and reading all the way to the end. The data is all laid out in one big continuous chunk. The drive can just stream it super efficiently. This is your big movie file. It's a perfect scenario for any drive. But then there's the second language, random I/O, and this one is messy. Forget the book. This is like trying to find 100 different sticky notes you've left all over a chaotic room. The drive has to jump all over the place, grabbing tiny bits of data that aren't next to each other. This is exactly what happens when your operating system boots up, when you launch an app, and yep, when you're copying thousands of small photos. It's the source of that sluggish feeling.
So why is random so much harder? Well, for a traditional spinning hard disk drive, an HDD, the answer is just pure physics. We are literally talking about metal parts that have to move.
See, for every single tiny file it needs to grab, a little arm inside the hard drive has to physically swing across a spinning platter to find the right track. That's called seek time. Then it has to wait for that platter to spin around so the data is right underneath it. That's rotational latency. And it has to do this little dance for every single file.
Now get this. On a typical drive, just those two physical movements add up to about 17.6 milliseconds of what I call dead time. Now that might sound incredibly fast to us, but in computer terms, it is an absolute eternity. And remember, that's the penalty you pay before even a single byte of data gets transferred.
And when you do the math, it's kind of shocking. You take 1 second, you divide it by that 17.6 millisecond delay, and you hit a hard physical wall. The drive can only perform about 57 of these random operations per second. That's it. We call that IOPS, and that number right there is the root of all slowness on a mechanical drive.
And this quote just says it all. When you're copying all those small photos, your hard drive isn't really a data transfer device. It's a machine that just moves its own parts around. It spends almost all of its time getting ready to work and almost none of its time actually doing the work. It's incredibly inefficient.
So, how do you solve a problem that's baked into physics? Well, you change the game entirely. And that's where the solid-state drive, the SSD, comes in.
The absolute magic of an SSD is that it has zero moving parts. It's all electronic. So that access time we talked about, that physical delay, it doesn't go away completely, but it drops from milliseconds, that's thousandths of a second, all the way down to microseconds, millionths of a second. It is literally thousands of times faster at just finding the data it needs.
Okay, theory is great, but let's see how this massive physical difference actually translates into the performance numbers you see on the spec sheets.
Now, check out this table. That first column, sequential read, that's our big movie file speed. It's the number everyone advertises. But look at this second column, random read IOPS. This is the number that translates to real-world snappiness. The hard drive is stuck down there around 150. A basic cheap SATA SSD, it jumps to 10,000. That's not just a step up, that's a different stratosphere of performance.
And this chart shows you exactly what that means. Loading a game from a hard drive takes nearly a minute. Just moving to a basic SATA SSD cuts that time almost in half, down to 30 seconds. But now, look at the jump from that pretty good SATA SSD to a super fast, super expensive NVMe drive. You only save 2 more seconds. You're seeing the law of diminishing returns in real time.
And this is the most important takeaway of this whole thing.
The single biggest, most mind-blowing performance upgrade you will ever experience is getting rid of a spinning hard drive and replacing it with any solid-state drive. It doesn't have to be the fanciest one. Once you eliminate the physical movement, you've solved 90% of the sluggishness problem right there.
Now, that's not to say hard drives are useless. They're still fantastic for storing huge amounts of data cheaply. But if you are buying one, you need to know how to see past the marketing nonsense to get the right tool for the job.
Let me save you some money right now. A gaming hard drive? It's a sticker. It's just a marketing term for a standard desktop drive. A NAS drive, on the other hand, is actually different. It's engineered to run 24/7 with special sensors to handle vibration when it's packed next to other drives. And it has firmware built for reliability in a server.
But this right here is the one you really have to watch out for, and it's often hidden in the fine print. CMR versus SMR. CMR is the classic, reliable way to write data. SMR is the newer tech that lets manufacturers cram more data onto a disk by overlapping the tracks, kind of like shingles on a roof. The problem is, under heavy sustained use, like in a NAS or a server, an SMR drive's performance can suddenly and completely collapse. It is incredibly dangerous to use in a RAID array and can actually lead to total data loss.
Okay, so let's bring it all home. We've been through the physics, the I/O patterns, the tech. Let's get back to that original agonizing problem. How do we speed up that photo library transfer?
The fix is brilliantly simple, and it takes about a minute. Before you even think about copying those files, just select all of them, right-click, and add them to a single compressed folder, like a zip file. Then, you just copy that one file.
So why does this black magic work? Because you've changed the language you're speaking to the drive. You've taken the absolute worst-case scenario, thousands of chaotic random writes, and you've transformed it into the drive's absolute favorite thing to do. One big, clean sequential write. You're working with the physics of the drive instead of fighting against it. So there you have it. You've now mastered the secret language of your storage. You know the difference between the big marketing number and the random performance that actually makes your system feel fast. You know the pitfalls to avoid, and even a trick to speed things up. The only question left is, now that your storage isn't the problem, what's the next bottleneck holding you back? Thanks for watching.